Hello and welcome back. Today we're talking about machine learning paradigms. Now, paradigms are are unique ways for a machine or a model to learn, and there's three main ones of them in machine learning, and you need to know them for the exam. The first one is supervised learning. For example, regression and classification, both of those fall under supervised learning. And here we can see a beautiful image of people supervising a machine. And how do you supervise a machine? Well, what you do is you provide input data with labels. In this case, you've got input data with annotations. These are apples. But it might be, for example, data about patients with lots of information like their blood test results, their weight, their smoking history, family history, and so on, like lots of columns for input data. And then the annotation or the label is whether or not they have a diabetes. So basically, you're giving the machine examples of past observations with answers. Each one of those observations has an answer to learn from. And so the model then digests this, and then next time you give it an example like of an image, or you give it an example of a patient, like columns of the same information, like a new patient, you give them their weight, their smoking history, their family history, and so on. And then the model will be able to, from that, predict what the answer for that new observation is. But like, again, the main thing here is that the input data already had those answers for each row or each observation or apples or whatever it was for the model to learn from. That's the supervision. The supervision is providing the answer during training. Now, unsupervised learning, for example, clustering falls into this category, is when you provide data without any answers attached to that data. So you just give it lots of data. For example, you give it it could be lots of patient data with their smoking history, their weight, their family history, and so on, but no answer, yes or no, do they have diabetes? Or you could give it lots of images of different fruit, but no labels. What is a banana? What is an apple? What is a pear or a peach in this case? You just give it all that data, and it has to figure out on its own how do they group. So how do they cluster together? So it would cluster all the apples together because they kind of look similar. All the peaches look similar. All the bananas look similar. So it'd be able to cluster them. Similarly, with patients, it wouldn't know which patients have diabetes or not, but based on the inputs, it would be able to cluster them together. And you might find groups of patients. And this is very useful when you're exploring new data that you haven't seen before. For example, you have customers in your business, you have information about their purchasing patterns, but you don't know how to group them. You don't have specific ideas on how to group them. Well, unsupervised learning can help you determine that grouping or those clusters. And reinforcement learning is the third type. And what we do is you give the model rewards and punishments, quote unquote, rewards and punishments, basically feedback for the actions it takes. So here's an example. Let's say you have a labyrinth, and the agent or the game starts with the player, in this case, the machine learning agent, being in that corner, and they need to get to the flags and avoid the fire at all costs. So if the agent moves into the fire, this type of training would give them a penalty of -100, just -100 units of reward. It's basically just a number coded into a variable, but the agent is trying to optimize to get the highest reward. So they can do actions in this environment, and they need to optimize to get the highest reward. So they would learn not to go into the fire very quickly because their reward is being diminished by 100 every time they do that. If they make a successful step, they get a +1, +1, +1. They would get a +1 going here, but here they would get a +100, right? So basically, this through trial and error, like the agent would play this game many, many, many times, and eventually they would figure out which way is the best way to go. How do they maximize their reward? So they don't really know about the flags or the fire like that. Those are all things that we know about. They just know about their reward. They want to maximize their reward. This is how, for example, self-driving cars are trained. They are trained through reinforcement learning, where for example, they need to stay in the same lane all the time. If they get out of the lane, then they get a negative reward. If they stay in the lane, the longer they stay in the lane, the more they get reward. So they learn to keep staying in the lane to maximize their reward. And that's how we get them to get to the destination. They don't really think about the destination. They think about maximizing their reward. So that's reinforcement learning. So those are the three types of learning. That's all you need to know for the exam. You don't need to know the details. Just remember the three different types: what they are and some examples, and I've put some examples here in the text for this slide. And there we go. Hope you enjoyed this, and I look forward to seeing you back here next time. And until then, enjoy the cloud.